In this video, we're going to take a look at setting up authentication for EIGRPv6 in a network. Basically, what we're trying to accomplish here is prevent the introduction of any unauthorized or false routing update messages from entering our routing environment. So we're going to accomplish this by enabling MD5 authentication on all of our routing updates that are coming from that EIGRP routing protocol. We're going to look at setting up basically keys that are going to help us that have different lifetimes as far as when they're valid, when they can be sent. The combination of the keys as well as the interface that's tied into EIGRP are going to uniquely identify the authentication algorithm and the key that's actually in use for that. So it's a pretty secure way to do this. It helps protect us a little bit. And it's certainly, for the effort put forth, a pretty good thing to have enabled on your network. Now it's going to work a little bit differently than OSPF v3. The authentication in that takes place actually with IPsec tunnels, but really accomplishing the same end goal here. Now in this environment, you can see all of the networks that I have. I've configured EIGRP on all of these routers, and I can pull one up just to quick show what that configuration would look like. So if we take a quick look at our running config, we'll see the interfaces that I have enabled for EIGRP. So 1337 would be my autonomous system number. And if you go down to EIGRP's configuration, again, we see the autonomous system number here. I've just made up router IDs for it. And then, of course, you have to enable the protocol in 12.4 of Cisco's iOS. Now, another thing that's going to be important when you're doing EIGRP key authentication is that you have the clocks set to a reasonably close time across all of your routers. Now, in a production environment, I would assume you'd be using NTP or some other way of keeping your time synchronized. In Packet Tracer, I don't have that set up, and you can actually see if I do a clock set, the clocks are going to be horrendously out of date. Rather, it's a show clock, not clock set. So they are, like I said, super out of date, but the big important part for this example is more so that the clocks across all of the routers are at least very, very close in time. So let's jump into this. We can also see one more thing here just to verify that EIGRP is working. If I do a show IPv6 route, we can see the EIGRP routes coming in from across the network. So we have, looks like effectively 2 of those. And we could use some other testing like pinging and things of that nature as well. Just going to jump into the configuration here. So we're going to start out in config T. We need to go to the interfaces that we actually have EIGRP enabled on, so more specifically between the routers, and we'll enable the authentication that way. So let's take a look here at our diagram. If I'm on the Madison router and I'm connecting to Corp, we're going to set up the EIGRP authentication on serial 000. So I go into interface, serial 000. Okay, the interface is already enabled and it's turned on. And we're going to start out with the authentication mode that we're going to set here. So the syntax for that is IPv6 authentication mode EIGRP. We set our autonomous system number, and you can see the different modes. In Packet Tracer, I believe we're stuck with just MD5, and I want to say in some of the newer versions of iOS you can actually do SHA hashes as well. But really the same syntax, just a little bit different hashing algorithm. So we've enabled MD5 authentication for it. We also need to enable the authentication of EIGRP for those IPv6 packets. This is accomplished through using a keychain. The way this looks is we'll do an IPv6 authentication keychain EIGRP. Next, we have to specify the autonomous system number. So again, that was 1337. And we give it a keychain name. So it's going to say EIGRP keys. Okay, so a keychain is going to hold a variety of different of these MD5 keys that we can have. But a really cool thing about it is we can specify how long those keys are valid for and when we should stop accepting them. So this allows us to set up key rotation that will happen automatically based on the dates that we configure for it. But the idea of the keychain is that we're going to hold multiple keys for this process. So I can actually back out of the interface, and we're going to get into the keychain here. So just from config mode, we're going to go keychain, EIGRP keys, and we'll enter into that. And it's pretty simple. We just start to enter a number of keys here. So I'm going to say key 0. You can see you can create quite a large number of different keys. And we'll set up the phrasing for it. So key string, and I'm just going to use something simple like password 1 bang. You'd obviously want to use something a little bit more secure than that. And you can see what it's talking about before, the accept lifetime. So how long do you want to receive that key and actually say yes, that's valid. Send lifetime as well when you're trying to authenticate with a peer. How, when do you need to stop trying this key and move on to a new one? We're not going to set those for now just because of the clock issues I have basically in this environment. But that's your, really basic configuration of EIGRP. Now the cool thing about this is if I set up another key, so let's actually just add one more key in here. So I'll do key 1 and set this up with another simple password. And there we go. Since I didn't set up any accept lifetimes or send lifetimes, the way this works is that when my router tries to authenticate with the neighbor router, it's going to start off at key 0, try that, and if it fails, it goes to key 1, and so on and so forth. The idea is that it starts with the lowest number key and then increases that value until it finds one that works. That new key is then used until the accept lifetime or the send lifetime expires, and then you need to move on to a new key. So I'm going to back out of all this, and let's go over to the corporate router here, and kind of walk that same setup of enabling the authentication and also setting up the keychain as well. And you can see it's kind of coincidental. We popped onto this router and see the authentication failure between these two neighbors. So, of course, we're going to need to have matching keys on either side of this, and we can go ahead and set that up. So from enable mode, we're going to go back into config T and start out with our interface. So serial, looks like 000 is connecting back up to Madison, so we will go there. So interface serial 000. Once we're on that interface, it's already enabled for EIGRPv6. It's not shut down. So we'll set up the MD5 authentication mode as well. IPv6 authentication mode EIGRP. Our autonomous system number matches across all of our routers. And we'll set it up for MD5 authentication. We then tell it which keychain to use, and we'll later configure that keychain. And this is 1337 again. I'm just going to use the same keychain name just to keep things consistent. Perfect. We can exit out of the interface and go to that key. So we can go into keychain. And we call it EIGRP keys. We create our first key, which would be key 0. And we can set up a password. Now you see, as soon as that password matches one of the passwords used in the keychain on our neighbors, we get that adjacency up, and everything is formed here as well. We can kind of verify a few things again if we wanted to, just from our privileged exec mode to kind of see, is this working, and kind of how do we look at that a little bit. Easy one to do would just be a show IPv6 EIGRP, and we could just look at our neighbors. What we're really looking for is just that these are in an up state. They're exchanging routes. Of course, if we looked at our show IPv6 route table, right, we see those routes are now back in there and everything should be good that way. So in a nutshell, that is how we do EIGRPv6 authentication. Something that doesn't take a lot of effort, but when you really dive into it, can kind of help protect your network from those, unauthorized or invalid routes causing a little bit of havoc.